AI has come a long way since its first appearance in 2022. When ChatGPT first came along, making a simple game such as Flappy Bird was almost an impossible task. It would take many attempts to build correctly. However, since then, we have come a long way. Modern AI has been able to make websites, larger software, and even Minecraft clones. So, with every improvement and iteration to ChatGPT, I naturally became curious. How far can we push ChatGPT? What is it truly capable of? And in this video, we're going to do just that. We're going to be testing OpenAI's 5.4 model. OpenAI boasts some crazy performance leaps over previous models. And in order to see what the model is truly capable of, we're going to need to push it. And the best way to do so is to ask it to make a ray tracer from scratch. The rules here are simple. There cannot be any human intervention. That means we cannot write or edit any line of code, even if it's a singular line. And the second rule is that we will be counting the amount of prompts it takes us to get the correct result. So before we even get started and build this, I need to explain what a ray tracer even is and why it's so complex to build in the first place. And to understand that, we need to take a look at how game lighting would work traditionally. You see, ever since the beginning of gaming, lighting has been a simple calculation where each object in the scene would be tested against a light source. And the amount of light that object receives is based on the object's orientation and where the object lies in the world. This was a fairly simple technique and it was called direct lighting and worked well with the hardware at the time. And this worked through the 1990s and almost up until now, games have been using this technique. However, as you can imagine, it just wasn't realistic enough as it did not simulate the way light behaves in real life. Ray tracing is the solution to that. By mimicking the exact way light behaves in real life, graphics can actually look very close to real life. The scene on the left is a scene lit by direct lighting, and the scene on the right is a ray trace scene. The difference here is massive. But this still might not explain why it's so complex or hard to build. As many of you already know, ray tracing comes with its complications. It completely tanks performance in almost any game. And it's for that reason that ray tracing has only been used in animated films until recently. Just to paint the picture of how complex this is, each ray of light that were to hit an object will bounce off the object and get tested for an intersection among all the other objects in the scene. In total, in a singular second, there could be billions of rays, even tens of billions of rays, that must go through triangle intersection tests, which are very difficult to run on modern graphics cards. So personally, I don't know if ChatGPT will be able to do this. And the bigger question here is, can it do it with performance in mind? But this is a video about pushing ChatGPT to its limits. So without wasting time, let's jump over. So here we are in ChatGPT. I feel like it's best to set the criteria for what we want to make before we even get started. It's important to understand the scene that we want this to be in. So for the scene, I've chose to use a popular scene called the Cornell box. If you don't know what the Cornell box is, it's essentially a popular ray tracing scene that people use to test ray tracers. The reason it's so popular is because usually you'll have one red wall or colored wall on each side, and it's perfect for testing indirect light bounces, such as this picture right here. You can also test reflections and soft shadows as well. And with that in mind, we're gonna go back over to ChatGPT, make sure that 5.4 thinking is set. And what a lot of people might not actually know is that you can actually choose how long you want ChatGPT to think. Beyond just putting GPT 5.4 thinking, you can actually go down here in the dropdown and hit extended. This actually gives ChatGPT a lot more time to think and give the better answer, which we're gonna need. Okay, so I basically have the prompt here. We're basically telling GPT to make us a ray tracer from scratch that runs on our browser. It will be in a Cornell style box. Inside this box will be a cone, a sphere, and a rectangle, and we will be able to control the position and scale and rotation. And there'll be a reset button to reset the positions of everything. There should be GUI that allows me to tweak the roughness, metallicness, and all other physical properties of the material. So hopefully it gets that right and make it performant. Obviously, we're gonna see if it's able to do it. We're asking a lot from it. I don't know if it can do it, but hopefully it can. I've also told it to ensure that all physical shadows are correct. It should take into consideration indirect light bounces, reflections, and soft shadows, and all while staying performant. So we're asking a lot. I don't know if it could do it, but we're gonna hit the send button and let's see what it comes out with. Alright, so ChatGPT got back to us. It actually took 13 minutes, almost 14 minutes to come up with that response. So I'm actually really curious what it cooked up for us. So we're gonna go ahead and hit download. We're gonna download that and I wanna take a look at what it made. I love the GUI. Let me see, maybe it says something here. No. Open the modern browser. Okay, so after reading this, supposedly the image is supposed to refine frame by frame over time. That's what the samples was for. However, we're not even seeing anything, so please take your time and fix this issue. So we're gonna have it look into that, and I'll get back to you guys once ChatGPT responds. Okay, so GPT actually got back to us quite quickly this time. It only took 53 seconds. So hopefully this one works. We're gonna go ahead and download that and let's give it another shot. Oh my god. This is so cool. Wow. It only took 2 attempts. It only took 2 attempts and it actually looks so good. So this graininess, this noisiness is expected because I think what's happening here is it's not calculating every single light bounce in one frame. It's kind of like accumulating frame to frame. So every time we make a movement, it recalculates, it readjusts. That is so cool though. This is very impressive. It's very noisy when we do move. Let's go ahead and adjust the width. Okay, so that actually adds more light and you could kind of see that in the reflection here. Let's zoom out. You can add depth to it. Wow, that really puts more light in the scene. We're gonna lower the intensity. 2 attempts. That's all. Yeah, AI is coming for us, guys. You can even see the soft shadow being formed, and if you look at the cone, there's a harder shadow because there's less light getting in there, while because this is higher up, there's more light reaching, so it's a softer shadow. And it's running at a smooth frame rate. Yeah, I don't see any visual flaws here. So I can even rotate, oh my god. Wow. We can scale that. Let's actually do something fun now. So what we're gonna do is we're going to change the color of the material. Specifically, let's do the sphere. So let's go to sphere and let's change the base color. Right now it's blue, let's maybe make it a little bit darker. So, and you see that darker color reflecting on that cone. So that's really cool. You also kind of see the sphere kind of reflecting on that left wall, on that left red wall. That's really cool. If I actually increase the metallicness, it's gonna look like completely like a mirror. But if I lower the metallicness and I increase the roughness, it kind of becomes like a rough ball. That is so cool. You can, there's an emissiveness to this too. So maybe we can make it blue. So maybe the emissiveness is a little bit off. I don't think it should look that way, but that's possible. That is so cool. It's putting out a blue light. Okay, we're gonna go ahead and reset the scene. Okay, we're gonna go back into, we're actually gonna play around with the cone now. Yeah, we're gonna probably like angle it this way. I'm gonna increase the roughness there. Oh, that doesn't look quite right. Maybe we lower the metallicness. There we go. Yeah. On the floor, I don't know if you guys can see, but over here there's kind of like a green hue on the shadow, and that's from the light bouncing off of this top area light, hitting that green wall and going down. It's just, yeah, this is, I know I've said it many times, but this is phenomenal. You also get a little bit of green up here. I think that's part of the reflection. So we're actually gonna do something pretty fun here. I'm gonna reset the scene and I'm gonna see if I can change the color of the area light. So we're actually gonna make it maybe green color. Maybe that's too strong. Let's go over here. Okay, now let's try blue or purple, a little bit purplish, purple and blue. Let's try red. Yeah, this is just amazing. Wow. Well, drop in the comments what you guys think. Was this impressive? This was 2 attempts, by the way. This was 2 prompts. This actually increased the area light actually. Oh wow, so that actually just puts out more color. Okay. Okay. Let's try, what other color should we try? Purple, magenta. Wow, this is strong. And obviously we can play around with the position of all these things and it just moves so quickly. We can just move this up here. Let's actually take a look at the code and see what it took to get here. I'm actually really curious. Okay, so here's what we're working with. So this sort of looks like this is the GUI. Yeah, we see like font related things over here. Cool, cool, cool. Yeah, this is really impressive. Two attempts, man. Wow. Okay, so this must be the shader. So if you guys don't know what a shader is, it's basically the code that actually runs on the GPU. And this entire time my GPU wasn't even getting hot or being used that much. So like, to answer the elephant in the room, yeah, it's very performant. 1,300 lines of code. Take a look at that, guys. What is going on here? If essentially one line in the math is wrong, kind of like what we saw with the first prompt, something will be wrong. Some sort of calculation will be wrong and it will mess up everything. At this rate, I don't know what GPT 5.5 is gonna be, or GPT 6. I don't know. It's, yeah. This was way better than I thought. Let me know what you think, and let me know what I should try making ChatGPT do next.